This is Unit 3, Video 7. In this video, we'll finish talking about the elements of the periodic table. And so the question we begin with is, what is the most common element in the entire universe? And you guessed it, it's the very first element on the periodic table, hydrogen. Hydrogen is element number 1, and it is actually the first element, and it's the most common element. So it's number 1 in terms of on the periodic table and in the universe. Most of the stars are actually made of hydrogen. Now, what's the second most common element on the periodic table and in the universe? And that would be helium. So helium, group element number 2, is actually the second most common. And the reason for this is because stars actually convert hydrogen into helium. So most of the universe is made of stars. Our planet is really tiny compared to a star. And stars convert hydrogen into helium through something called fusion. It's a nuclear process. And that's why these are the two most common elements in the universe. Now, hydrogen is very special. Hydrogen has physical properties of gases. It itself is a gas. If you fill a balloon with hydrogen, it'll float. And it has chemical properties of metals, which is really strange. And that's why oftentimes hydrogen is not placed anywhere. It's kind of placed in the middle of the periodic table and kind of hangs there. Now, most of the periodic tables actually contain hydrogen right here. And they put hydrogen with the metals. Remember, these right here are alkali metals. And hydrogen really doesn't belong. However, it's placed here because hydrogen has a +1 charge. You'll see it reacts to have a +1 charge, just like lithium, sodium, potassium, rubidium, and cesium. And that's why it's placed in the first group with the alkali metals. It doesn't really belong on the right side because most of these elements, as you'll see, form a negative charge. -1 charge, -2 charge. Hydrogen forms the +1 charge. And because Mendeleev linked, or not linked, but arranged the elements based on their properties, that's why these belong together. Now, the periodic table is broken up into what are called blocks. We're not going to go into why these blocks exist, but I want you to be able to see it. You can definitely visually see the 4 blocks on the periodic table. These actually represent something called subshells, where electrons exist. So, eventually when you take chemistry, you'll see how the periodic table contains the structure of the electronic structure is seen in the periodic table, and these are seen by blocks. This here is the S block, which contains the alkali and the alkaline earth elements. This is the P block, which contains the noble gases that we've talked about, and most of the nonmetals, like the halogens. This is the D block, which contains metals, essentially. And then this is the F block, which also contains metals, but these are rare earth metals. So these are the 4 blocks of the periodic table. You can now see how they're arranged. Now, the D block has a certain number of elements in it. If you count, you'll count 10 elements. And this will refer to the 10 electrons in the D subshell. There are 10 electrons in the D subshell. And you can count the rest of the blocks, how many elements wide they are. So the periodic table actually shows you a lot more than just the elements arranged. It shows you in this case, for example, shows you the electronic structure of the atom. The main group elements are then the S and the P block elements. So your main group elements are here, 1 and group 2. And also group 3, 4, 5, 6, and 7. All the rest of these are called main group elements. And so oxygen, for example, is considered a main group element. Calcium is considered a main group element. The transition elements are actually the D block elements, so that would be in the middle of the periodic table. These are the D block elements. Now, most of these are metals. Actually, all of them are metals. And most of them look like this. This is the element iron. Iron has the symbol Fe. They are silver looking, they're shiny if they're pure, and you can't really tell the difference between them. Most of the metals, if I bring a sample up to you, you won't be able to recognize them. They all look the same. Now, there are a few exceptions to this. Everyone would be able to recognize this element. This is element copper, element number 29. And everyone will be able to recognize this element because it also is not silver. This is gold, element number 79. Copper and gold sit right above each other, or the gold is below copper. Now, a third element people will probably be able to recognize is this element, because it's a liquid. This is mercury, element number 80. So these three elements you can probably visually recognize, but the rest of the D block elements will look like this. They'll look like silver, shiny metals. There is a group on the D block called noble metals. Now noble, just like the noble gases, for us will mean unreactive. In other words, they're not going to react. And these contain gold. Gold is the famous noble metal. In fact, gold is used whenever they find gold, say in archaeological digs, the gold is still pure. The gold is unreactive. It still looks like gold, even though it was sitting there for thousands upon thousands of years. And they actually use these unreactive metals into rings and jewelry. So the reason for this is because they're also precious. Now the word precious means it costs a lot. So they're precious, meaning they cost a lot of money. And they're precious because they are rare. And anytime something is rare, it then becomes precious. So it not only is unreactive, but it's also a precious metal. Some other ones you may have heard of are platinum. Silver is also in this group. Palladium is also in this group. And oftentimes jewelry actually is made from these four elements. Anytime you have a ring, a gold ring, usually it's not pure gold. It's usually alloyed with platinum, maybe a little bit of silver, maybe a little bit of palladium. You can get yourself a platinum ring, you can get yourself a palladium ring, and so forth. So these are the noble metals. And then we have the rare earth elements. These are also metals. These exist in the very bottom of the periodic table, the F block. And they also have interesting properties. Now they're rare earth because they're also rare in the earth, so they're also kind of expensive. Not as expensive as gold, say, but these are also expensive because they are rare. An example of it is element number 60, which is neodymium. Neodymium is what the magnets, the modern strong magnets are made of. Notice here a magnet is able to pull up a whole bunch of paper clips through the human hand. And here's a sculpture made of neodymium magnets where there's a gap because you have two neodymium magnets essentially that are attracting, and you tie them up and you get this little sculpture. There's about 14 in each row, so about 28 total. And these are also called the lanthanides and the actinides because it begins with lanthanum and actinium. The lanthanum and actinium are still actually part of the D block, but right after them, the F block elements begin. So that's why they call these the lanthanides and the actinides. And then we have the radioactive elements. Anything above 84, element 84 is polonium. Anything above 84 is radioactive. Now, radioactivity means that the nucleus, which is in the center, begins to break apart, begins to decay. And that's because it's too big. And when they decay, essentially it falls apart, and it falls apart into smaller elements. So here, for example, you have, this is plutonium, radioactive plutonium, element number 93, which is glowing red, and it's glowing red because its nuclear decay produces energy. And so anything after 84, notice plutonium being 93, is quite a bit beyond 84, and so it's radioactive. There are two elements that are earlier in the periodic table that are below, or above, we'll say, above 84, and they are technetium and promethium, and they are also radioactive. And you'll see this graphically on the next slide. So here's the periodic table. Your periodic table may not be able to distinguish between these, but anything red here, if you want to color them in as red, would be radioactive. So if you want to color these in, or kind of circle them, notice that technetium is high above on the periodic table. It's element 43, and it's radioactive, and so is promethium. Promethium is element 61. So 43 and 61, which are above the 84, are actually radioactive. But then, beginning with 84 and on down, all of them become radioactive. So all the elements beyond polonium, which includes all these elements, and includes these elements, and all the way to the end of the periodic table, they are all radioactive. And that's kind of the idea. Right, so that finishes video 7. We'll take a look at periodic trends in the future video.